To date, we've struck over 7,000 targets across Iran and its military infrastructure. That is not incremental. That is overwhelming force applied with precision. And again, today will be the largest strike package yet, just like yesterday was.
Every U.S. strike aircraft that enters Iranian airspace does so because something went first. Not a bomb, not a missile. A signal. An invisible wall of electronic noise that floods Iranian radar screens and renders them useless. The pilots behind those radar screens see nothing. The missile batteries connected to those radars cannot lock. The air defense network that Iran spent decades building goes dark. The aircraft that does this is the EA-18 Growler. It is operating from USS Abraham Lincoln right now. Before every strike, every time, Iran's air defense network is not a single system. It is a layered architecture, multiple radar types, operating at different frequencies, covering different altitudes, feeding targeting data to surface-to-air missile batteries positioned across the country. Some radars scan at long range, detecting aircraft hundreds of miles out. Others operate at shorter range, providing precise targeting data to missile systems close to the target. They are connected. They talk to each other. A strike package entering Iranian airspace triggers multiple radar types simultaneously, each one attempting to lock and pass the target to a missile battery. Defeating that network requires more than stealth alone. It requires active suppression. The EA-18G Growler is based on the FAA-18F Super Hornet airframe. Same fuselage, same twin engines, same catapult launch capability from a carrier deck. But where the Super Hornet carries bombs and air-to-air missiles, the Growler carries something different. The ALQ-99 jamming pod system, multiple pods mounted on the underwing pylons, each one generating powerful electronic signals across specific radar frequency bands. When the pods are active, they flood the electromagnetic spectrum used by Iranian radar with noise. The radar operator's screen fills with interference. Solid returns disappear. No aircraft appear. The network is blind. The Growler also carries the AGM-88 high-speed anti-radiation missile. When an Iranian radar system activates and begins transmitting the moment its signal enters the air, the HARM missile detects that signal, locks onto its exact source, and guides itself directly back to the radar antenna. Flight time to the target is measured in seconds. The logic for an Iranian radar operator is brutal and simple. Turn the radar on and a missile follows the signal home. Keep it off and U.S. aircraft pass through undetected. Either way, the radar does not protect what it was built to protect. On the flight deck of the carrier, the morning sun is already above the horizon. The deck is active. Aircraft are being moved, positioned, armed. The EA-18G sits on the bow catapult, wings unfolded and locked, jamming pods mounted on the underwing stations. Ordnance men move around the aircraft, checking each station methodically. The AGM-88 HARM missiles are inspected, 4 of them, 2 under each wing alongside the jamming pods. The seeker heads are uncovered. The arming pins are confirmed in place with red safety flags hanging from them. The AIM-120 air-to-air missiles on the wingtip rails are checked. External fuel tanks are confirmed secure on the centerline station. The aircraft is carrying a full combat load. A second crew member occupies the rear cockpit, the electronic warfare officer. This is the person who operates the jamming systems in flight, monitors the threat display, and makes real-time decisions about which radar systems to jam and which to engage with the HARM. The pilot flies the aircraft. The electronic warfare officer fights the electronic battle. Both crew members arrive at the aircraft and conduct their walk around independently. The pilot checks the airframe, the control surfaces, the engine intakes. The electronic warfare officer moves to each jamming pod, checking the antenna faces on the front of each pod, the mounting hardware connecting the pod to the pylon, the data link cables running from the pod to the aircraft's electronic warfare management system. The pods are the mission. Everything depends on them functioning correctly in the electromagnetic environment over Iran. They are checked twice. Both crew members climb into their cockpits. Canopies lower and lock. In the front cockpit, the pilot brings the aircraft system's online avionics, radar warning receiver, fuel systems, engine instruments. Radio checks are completed with the carrier's Combat Information Center and with the E-2D Hawkeye already airborne overhead. orbiting at altitude, tracking every radar emission and aircraft movement across the entire theater. The jet blast deflector rises behind the engines. The pilot advances the throttles to full power. The airframe shudders against the holdback, fitting on the catapult. The catapult officer checks the deck is clear, drops to one knee, and points forward. The holdback releases. The aircraft accelerates from 0 to flying speed in under 3 seconds and launches off the bow, dropping slightly before climbing hard into the clear morning sky. The aircraft climbs and turns northwest. The Arabian Sea passes below. The electronic warfare officer monitors the threat display as the aircraft climbs toward its operating altitude. The E-2D Hawkeye overhead is already passing threat data, the location of active Iranian radar sites, their frequency bands, their current emission status. As the aircraft approaches the edge of Iranian radar coverage, the threat receivers begin picking up signals. Each signal is identified automatically by the system radar type, frequency band, approximate location. The electronic warfare officer reviews the threat picture and selects the jamming response for each. The pods begin transmitting. On Iranian radar screen static. The returns that should be showing U.S. aircraft are buried in noise. Operators increase receiver gain trying to burn through the interference. The picture does not clear. The strike package following behind the Growler-loaded F/A-18s and F-35Cs enters Iranian airspace. No radar locks. No missile guidance signals. The batteries that should be engaging the incoming aircraft have nothing to engage. They are firing blind in the empty sky. An Iranian radar site attempts to overcome the jamming by increasing its own transmission power. The moment it does, the signal strengthens. The harm seeker on the left pylon detects the increased emission. Lock tone in the pilot's headset. The missile fires. It follows the signal to its source. The radar site goes off the air permanently. The electronic warfare officer adjusts the jamming pattern to cover the frequency bands still active across the network. One by one, the signals drop off the display. The corridor into Iranian airspace widens. Back on the carrier, the next Growler is already on the catapult. Same weapons load, same crew configuration, same mission. The jamming does not stop between strikes. The network cannot be allowed to recover between runs. The moment it recovers, the corridor closes and the strike packages behind it are exposed. The catapult fires. The second aircraft launches. The corridor stays open.